Hey everyone, welcome to a new video. It's Federico here. In this video we're going to see how we can implement a camera to move around our three-dimensional scene, and then we are going to see which light types we have available in computer graphics and especially in Jitter to make our scene look more as we want it to look, so either more realistic or more fantastic. So we're going to explore all of that, so if this sounds interesting, stick with it and have fun. Let's start! So this is the patch as we left it in the previous lesson, and let's actually get rid of everything that is in this patch. We are going to do everything from scratch once more. So what we're going to do is to create a scene that we will use as our playground also for the next lessons. So let's start by creating a bunch of 3D objects, and I'm going to create grid shape objects. And the first object I want to have is some sort of a ground for our 3D world. So what I'm going to do is to assign this shape to, we could assign it to a plane for having this ground, but what I will do is that I will assign it to a cube because I want this ground to have a certain depth. I don't want to be it only a flat ground, I want to have it a certain height. So what I'm going to do then is to scale this object down on the y-axis, right? Because I want this to be a ground, so I want this to be fairly thin. And then I'm going to position it also a bit below, so it's not exactly on the center of the world, it's displaced toward the bottom of the world because we want to kind of build stuff on top of it. Okay, so what I'm going to do now is that I'm going to assign a material to this ground, and I'm going to connect a GGL material to it. Cool. Now, I got a bunch of textures from this website that I showed you in the previous lesson, and I put them all in a folder which I call Video 7, and this is where this patch is also residing. So what I want to do is to create a bunch of GGL texture objects that are going to load those textures and then send them into the inputs of the GGL material object. So for example, this one, I'm probably going to give it this ground texture, which looks like this. So in order to not have to every time just drag and drop these textures from the folders into the GGL texture object, I'm going to take the path of this patcher and then I'm going to build a relative path to the textures which are in the same folder where this patch is. So I'm going to use the dispatcher object to get the path of this patcher inside my computer. So if I click on path, you can see it will give me the path of the folder in which this patcher is contained. And then I can use the sprint object to concatenate to that the rest of the path that I want. For example, I want to attach to this ground, so this will go into the ground folder, and then I want to get the name of the color image, which is called like this. I will just copy that and then paste it here. And what I want to tell it is also to output a symbol, because if there will be spaces in this name, the path will be broken, but if we say sim out, it will output the whole path as a symbol, which then will work as a valid path. Okay, so this path looks good. Now what I can do is to just say prepend read to the GGL texture object and give it a go. Should have read this image. If we now try to bang that, we can see that the image is indeed inside the GGL texture. Awesome. Now, in order to automate this bang part, what I will do is to take advantage of the read message that comes out of GGL texture, like it comes out from JIT matrix as we saw in the previous videos. We saw that there is this read message that comes out from JIT movie, and this comes out also from JIT matrix and from GGL texture. So what we can do is to simply route the read message here, and then just use like list.asils, which if we set the value 1 will give us the last value of this list that comes in. So let's give it a go, actually from the right outlet. And great, then we can just say select 1, and then we can output this texture. So this should be all now nicely automated. So let's create a bunch more objects. Let's get rid of this message box. Let's copy this whole thing and create another one. And we are not placing it, well, this time we are placing it at 0, 0, 0, so, and it's not going to be a cube, it's going to be a sphere. and we are not going to scale it like this. We're just going to scale it as 0.5 or something like that. Great. And let's actually place the ground at minus 0.5 or like 0.6 or something. Okay, awesome. And let's mark it, and let's write here a little note that this is actually the ground. And then let's connect the path here from the dispatcher to the sprint object. And let's choose another material for the sphere. Let's choose, for example, this bricks material. So we just copy the name of this image, and then I have to replace here this whole part. I have to say bricks, then a slash, and then the name of this image. And let's see if this works. Yep, it seems to be working. And let's write here that this is the sphere. Let's actually make it, let's give it a bit more vertices, so it will look a bit smoother, like 100 by 100. Okay, great, this looks great. And we should do the same thing with the images for the normal maps, right? The normal maps, we used them in the previous videos, talking about these blue, the bluish images. These are called normal maps. We still will not see exactly what this is about in this video, but they are used to calculate the lighting on the object. So we used them in the previous video. We saw that when loading these normal maps, the object will look much more realistic. So the normals are indeed involved in the lighting calculation for the object. So for the moment, I want to show you how we can navigate in this three-dimensional world using a virtual camera. So let's stop for the moment here with our world building, and let's go on introducing a new object, which is the GGL Camera object. Actually, before we do that, let me encapsulate this part here, this texture part. Let's call it load texture or something. And as you can see, Max is giving me some sort of warning. Couldn't get texture object. We can fix that by simply rebanging that texture, or actually loading it first, and then this warning will go away. This basically means that the GGL material cannot access anymore the texture that was sent to him before. So let's do the same thing here with this other texture object, and again we will get the same message. Let's call it load texture. This will be a nice case for an abstraction, right? We could transform this little object in an abstraction. Actually, probably we are going to do that in some future videos, not now. So let's load again this image as well. Cool. So we were saying GGL Camera, right? Let's create it. Let's actually place it above these 3D objects. So here, let's create a GGL Camera. And nothing happens because the camera was already existing. We just now made it explicit. So in order to visualize exactly what the GGL Camera does, you have to imagine we have our 3D world, and we also have objects in it. And our camera is our point of view, where from we are looking at this scene. So you can imagine that here, there is a little camera which represent our eye, and this is the point from where we are observing this scene. So you can imagine if this will be our camera with that perspective in the final rendering window, we will see the object seen from that perspective of the camera. So now this is a bit complex to draw, but you can imagine this will be the cube seen from the side, and that will be this house seeing from the side, which only partially is inside the field of view of the camera, right? So it's kind of cut out. Great. So with Jitter, we can take control of this GGL Camera object. So let's see how we can do that. For example, this camera has a position in this 3D world. It's like you can think about it as a 3D object itself. So here we can change the position attribute of the GGL Camera. So let's create a pack object, call it position, and by default it's not going to be at 0, 0, 0 because the center of the world is at 0, 0, 0, right? By default the camera is going to be somewhere here along the z-axis. The camera is going to be at 0, 0, 2 on the z-axis. So a bit farther from the center of the world on the z-axis. In fact, if we look at its position attribute, by default we will see that it's set at 0, 0, 2. So we could set it here, our pack object, to reflect these default values. And now we can modify the position of the camera using flow_num objects, for example. So we can change its Z position, it can be very close or inside the object even, or we can go farther away from it. We can go above, we can go below, right? It's pretty nice. We can go on the right, we can go on the left. This is our point of view. Like in a video game, when you move your character, what you're doing is moving the camera that is shooting the scene. This makes me think that I actually would like to have our ground a bit bigger on the X and Z axis. So let's actually make it like 4 and 4, and actually thinner on the Y axis. So I'm going to say 0.05 here. Great, so now our ground looks more like a ground. Awesome. And let's change the color of the background to make it more similar to something like sky color. Yeah, something like that. Then we can use our same trick from last time. We can use the get erase color message to get the color of the background. And then I can just go here and paste it inside the JIT world object. There we go. So what I want to show you now is how we can modify the position of the camera and even its rotation. Not just using flow_nums, but actually using our keyboard, right? Using some keys on our keyboard. And this can be done using an object of the anim family, which is something that we're going to see in some future videos. But we're going to introduce this object first because it's useful to move the camera around. And this object is called jit_anim_drive. So let's connect the jit_anim_drive to our camera. And now what we can do is to set an attribute for the jit_anim_drive, which is called UI listen, and set it to 1. This means that now the jit_anim_drive will listen for keyboard and mouse input. So we can now move around in our scene by hitting the W to go forward, S to go backward, A to go left, D to go right, and then we can use Q to go up and Z to go down. So as you can see, I'm moving around in the scene using just my keys. Now this is a bit difficult to control because the speed is so fast, the camera is moving so fast. So we can actually adjust the speed of the jit_anim_drive. It has a speed attribute. So let's set it to something like 0.2. Not 2, but 0.2. So now it's going to go much slower, actually too slow. Let's set it to something like 0.8. By default, it seems it was higher than 1. So let's set it to something like 3. Yeah, this seems manageable. This looks nice. And with the mouse, I can also orient the camera to make it look at some other point. I can turn it, basically, using the mouse. Okay, awesome. Now, as you can see, sometimes the camera kind of tilts on its Z-axis, kind of rotates on the Z-axis, and this makes it look like if the world is actually tilting, right? We may not want that, so what we can do is to go into GGL Camera and set an attribute called tripod to 1. So we are telling the camera with this attribute to never tilt, basically always be parallel to the ground. You can imagine that our camera is now sitting on a tripod and therefore is looking at the scene and is never like tilting. So if we represent the camera here from the back, it's never tilting on this direction, right? It can only rotate around its Y-axis. So it can only rotate in this way. So if we look at the camera from above, it can only rotate in this way, but it cannot rotate on its Z-axis. Okay, that's what tripod does. And as you can see, the camera takes also a bit of time to slow down when I release my keys. This is best felt when you're doing this yourself. But if we want to reduce this amount of ease, this amount of time to actually stop or start, we can set on the jit_anim_drive the ease attribute to something smaller, like 0.1, for example. In this way, the camera will have very few ease, which means the movements are going to be a bit more sudden. But this could be something that is actually preferable instead of having this slow kind of easing in and easing out of the movement. 0.2 looks fine. So let's now introduce the second object, which is the subject of this lesson, which is the jit.gl light object. Because in the previous video, we saw how light interacts with 3D shapes, but we didn't see exactly what a light is. So in Jitter, there is this object which is called GGL light. And again, as for the GGL camera, when we create it, nothing happens because implicitly there was already a GGL light object inside the JIT world. It's the same as with the GGL camera. By creating it explicitly, we are getting control over this object. That's what is happening. So getting control of the light, it means we can change its attributes. For example, we could want to change the diffuse color, which is the light color that is diffused by the shape. We're going to see more about light mechanics in future videos, as I always say, but basically you have to think that the light is hitting the shape and then it's scattering and giving us back a diffuse light. So we can change this light color from the GGL light object, and this will basically change the color of all the objects in the scene which are interacting with the light. So we could give more like a sunset feeling to the scene, or we can give it a more morning feeling. Something like that. Then we can change the type of this light. We don't have only one type of light, but we actually have 4. So we have point, directional, spot, and hemisphere. So by default, the light is set to directional. And let's see how these light types look like. So let's say this is our ground, and this is our sphere on the ground. A directional light, you can think about it like as the sun. So the sun is the perfect directional light because it's so big and so far from us that we can think that all the rays of the light come parallel to each other to our shapes. Okay, so all the rays are parallel. This is our directional light. Then we got another type of light which is called the point light, and let's make it blue. You can think about a point light like a light bulb, for example. So a light bulb will emit light in each direction, right? So the light will go in each direction and will hit our shape from different angles. So this will hit our shape from different angles, which makes the way on which the light interacts with our shape different from directional light. Cool. Then we got a spotlight, and spotlight, as the name says, you can think about it like a little spot light that just casts light on a certain cone of light. So the light from the spotlight will only cover this cone volume. Cool. And then we got the hemisphere light, which it's a bit more complex, and we're going to see it in a future video. So here I forgot to write, this is the spotlight and this is the point light. So back to Max, let's try this different type of lights. For example, directional is our default light. With directional light, the only thing that counts is the direction in which this light comes from. So the direction by default is set to -1, -1, -1, which means that the light direction goes on the negative x-axis, on the negative y-axis, and on the negative z-axis. So this gives us a vector that, if you think about it in 3D, goes a bit like this. And then this you have to think is going on the negative axis, right? So this is going like from the front to the back. Okay. If we change this direction, for example, we can make it go on the positive direction, then you can see that the light is coming toward the camera in the positive Z direction. And it looks indeed like if there would be like a big sun somewhere there. You can make it actually like yellowish, the diffuse light. Then we got the point light, which in this case, it doesn't matter the direction, because as we said, for point light, the light comes from each direction. So what is important here is just the position of this light. So if we change the position attribute of this light, you will see that the light is going to come from another place. We can imagine that this is like a little sphere illuminating our scene. We can even represent it using, for example, a GGL grid shape with shape sphere. And let's scale it very small. And then let's use the position of the light also for the position of this little sphere. And let's make it even smaller. And then let's use actually the diffuse color as the color for these objects. So we can use the getAttr object to get the value of the diffuse attribute of GGL light. This will give us the value of the diffuse, and then we can just say prepend color, and then we can use that as the color for our shape. There's a little trick. So let's send a bang to the get attribute to get this attribute. And now we will have the light with the same color as the diffuse. So we can use that to represent it, a little token to represent our point light. Or in general, the position of our light. As we say with the directional light, it doesn't really matter the position, so this is not going to be useful for directional light. But for point and spot is going to be useful. So with the spotlight, the important attributes are the spot angle, the spot fall off, and also the direction. So the direction works in the same way as for the directional light. As you can see, in this way, we are going to have the light emitting light from here and covering this cone of light. We can change how big is the cone projected by this light, modifying the spot angle, and we can change where it's actually pointing. And then we can, with the spot fall off, we can smooth the edges of this cone, right? So that's pretty cool. We could have it like a more diffuse cone of light. Doesn't need to be so precise, like a very precise cone, but we can have it as a very precise cone if we choose so. And of course, we can have multiple lights in the scene. So we could have a spotlight, and then we could have another light. So let me actually encapsulate that. Light 1. And then let's create another one, let's call it light 2. By default, it's going to be directional as well, so it's going to be summed to the previous light. But what we want to have is, for example, for this light to be a spotlight. So we can hard code this attribute in the GGL light. And let's say type spot, or sorry, let's actually make it point light. And then we can choose a different position for it, like that. And we can, of course, hard code this attribute. So we can say position minus 1.2, 0.4, minus 0.2 or whatever. And then we can set another diffuse color to something like reddish. And then we can, of course, hard code this color. This is going to be simple. We just need to copy that from the getAttr output and then paste it here. And it's actually not called color, it's called diffuse, right? This is the color of the diffuse light. We can also change the color of the specular highlights. So in the previous video, we saw that an object can be represented as glossy if we give it these specular highlights from the GGL material. And with GGL light, we can change the color of those specular highlights as well. So this is called the specular attribute. And we could have a different color for specular highlights if we so choose. And the last thing I'm going to show you is that we can actually hard code those attributes in max objects in another way, which is if we go on this green triangle, click on it, and then we go into transform, and we click on changed attributes to arguments, you will see that the specular color is also hard coded, and also some other attributes that are automatically changed, like the draw to, which we don't really need. All the attributes that are changed are going to be hard-coded inside the object. Now, this doesn't work always perfectly. Some attributes are left outside of that, so in some cases you will have to do this manually, but in a lot of cases this actually works. So that's another way to hard-code attributes. Cool. So as an exercise to you, yes, I'm giving you exercises, I would like that you get the normals texture and apply them to the normal input of the GGL material, which is here the 5th input. So you download some texture that you like from the website that we indicated last time, and you get the color texture and you get the normal texture to give to this object a very realistic appearance. I just did it, and as you can see, it looks a bit extreme, but we're going to see how we can improve this look in the future. But it also looks pretty cool. You can, as always, grab this patch from my Patreon. This time I'm putting it in the lowest support tier, which is like €4 per month. And with that support level, you will be able to get this patch and all the other patches that are in that Patreon tier, which are actually quite a lot. Also, you get access to my Discord channel, so there is a lot of perks to be had, and you will also be supporting the channel, so thanks a lot if you choose to do so. So I hope this was fun, and I will see you in the next lesson. Take care. See you. Ciao.